Alright, so this review is going to help you do well on your sound and waves exam, I hope. Anyway, that's the game plan. Alright, so the first question says, what is the source of all sounds? Well, the source of all sounds is the vibration of particles. Okay, we call that vibration of particles sound. And we know that it is a longitudinal wave. And it has compressions. And rarefactions. Compressions are regions of high pressure where the molecules are close together, or the particles are close together. They're compressed. And this is regions of low pressure. They're spread way apart. Alright, number 2 says, how does pitch relate to frequency? Pitch is how we hear sound with our ear. So it's a relative term. And we say that a high pitch is caused by a high frequency, and that low pitch is caused by a low frequency. What is the average frequency range for human ear? This came right out of your notes. We can hear from 20 hertz to 20,000 hertz. Okay, the fourth question says distinguish between infrasonic and ultrasonic, so below 20 hertz we call infrasonic, and above 20 hertz we call ultrasonic. Okay, question 5. Get that out of the way. Question 5 says that distinguish between compressions and rarefactions. We just did that up there on question 1. We said that compressions were regions of high pressure, and rarefactions were regions of low pressure. See that on number 1. And then we said, part B said, how are each produced? And we said that compressions are produced by particles being close together, and rarefactions are produced when particles are far apart. And I discussed that in number 1. Okay, number 6 says, can sound travel through a vacuum? No, I talked about that in number 1. You have to have particles because they have to bounce into each other and vibrate. If it's a vacuum, there is no vibration of particles, there is no sound. Does its speed depend on the air temperature? Yes. So that was part A. For every rise in 1 degree Celsius, we hear, actually it'd be a better way to say it, sound moving 0.6 meters per second faster. So if you think back on that lab that we did with the water in the PVC pipe in the graduated cylinder, when the room was 26 degrees Celsius temperature, we said, well, 331 was the speed of sound at 0, but we were 25 degrees higher than that. So 25 times 0.6 is 15. And we added that to 331. And we found out the speed of sound on that day in our classroom was 346. All right, number 7. How fast can sound travel through dry air? Well, if it's at room temperature, 340 is about right for 20 degrees Celsius. And then it says, does its speed depend on air temperature? Yes, we already talked about that. Okay. Number 8 says, how does the speed of sound compare to its speed in water and still? Okay, so speed of sound is fastest in a solid because the particles are closest together. And then the next one would be the liquid is the next fastest because they're still close together, but not as close as the solid. And then gases are the slowest because the particles are far apart. So gases carry the speed of sound slowest because the particles are so far apart in a gas. Okay? All right, number 9 says, why does sound travel? Okay, we already talked about that. So I answered 8 and 9 together. Okay, number 10 says, why is a sound louder when a vibrating source is held to a sounding board? Because what happens is when you set a vibrating device on a sounding board, it causes the vibration of the board to increase and more air is disturbed, so you hear a louder sound. So let's say sounding board allows for more vibration. And that causes more air to be moved around. And your ear hears that as a louder sound. Okay. There we go. Okay, number 11. Number 11 says, why do different objects have different sounds when dropped on the floor? Because they have different natural frequencies. Different objects have different natural frequencies. So if I drop a cup on the ground, that's going to make a different sound than if I drop a big old heavy book on the ground. Different shape, different natural frequency, different compositions, okay? What does it mean to say that everything has a natural frequency of vibration? Because objects have size, shape, and composition, whatever they're made of. They have differing natural frequencies. Okay, number 13. Number 13 says, what is the relationship between forced vibrations and resonance? Resonance is, and this is what you did with the lab, you made the air column resonate. Resonance is forced vibration. At the natural frequency. Number 14, why can a tuning fork or bell be set into resonance while tissue paper cannot? Because tissue paper doesn't have, because of its construction, it really doesn't have much of a natural frequency. Okay, number 15, how is resonance produced in a vibrating object? So what happens is that the, let me see, I want to say this. You input vibrations. that match the object's natural frequency, that match the object's natural frequency.